Hello everyone. Today we are going to continue our discussion of quadratic equations and more specifically the quadratic formula. This is day 3 and this is the last piece of information that you will learn in our quadratic strand, and then we'll be moving on after that. Okay, so with these first examples, under example 1 we have A, B, and C, and all are asking us to use the quadratic formula to solve each equation. You can either fast forward this video now and do that on your own, or you can go through these steps again with us if you need some more practice using the quadratic formula. Okay, so the first one. Let's identify our A, our B, and our C values first. A is 1, B is -4, and our C value is -3. Okay, I'm going to plug those in to our quadratic formula. And B is -4, 4 times 1 times -3, divided by 2 times 1. If you simplify all of that, what you're going to get here, well, you get 4 out front. 4 squared is 16. Subtract 4 times 1 times -3, which is 12. And you end up adding 12. You get 28. Divided by 2. Remembering here we branch off. Our first value of x is going to be equal to 4 plus 28, or plus the square root of 28 divided by 2, and our second value is going to be 4 subtract 28 divided by 2. What does this equal? That's 4.65, and this is -0.65. Okay, so that was just like we did in our homework and in the last lesson using the quadratic formula, and we have two solutions. If we move on a little bit, okay, we look at B. Same thing, I'm going to identify my A, B, and C first. A is 2, B is -4, C is 2. Again, go ahead and plug those values into your equation. So we have -4 is B, plus or minus square root B squared minus 4AC, divided by 2A, or 2 times 2, sorry. If you simplify this, so you're going to get 4, and I'm going to break this apart. Here, -4 squared is 16, okay? 4 times 2 times 2 is 16, so this becomes 16, subtract 16, and that's 4. What you're left with here is x equals 4 plus or minus the square root of 16 minus 16, which is 0, divided by 4. Now, if you were to branch off here like we just did in the previous example, you would have 4 plus the square root of 0, 4 subtract the square root of 0, which is the same value. So there's no point in branching off here. All you really have here to worry about, because the square root of 0 is itself, is 4 divided by 4, which equals 1. In this case, you only have one solution, okay? And that is x equals 1. If you scroll back up, we had 2 solutions. Up until today, everything has had 2 solutions. So now there's a scenario where there's only one solution. Think to yourself, how would that make possible? Or how would that be possible? Because the solution is where that parabola crosses the x-axis. How can you only cross once given the shape of a parabola? Okay, hold on to that thought, and we'll continue into our third example here. So, I'm going to identify my A, my B, and my C, and I'm going to plug those values in. Okay, and I'm going to solve 16, and then 4 times 2 times 7 gives me 56, and this is 4, if I simplify it just a little bit further, I'm going to get 4 plus minus the square root of a negative 40 divided by 4. Now, if you're sitting there with your calculator, try this right here and see what happens. What you should be getting is error, okay? You should be getting an error. You cannot take the square root of a negative number. Now, that doesn't mean you're wrong in this situation, okay? When you get that portion of the quadratic formula which is under your square root sign, and it is equal to any negative number, okay, whether that's negative 0.1 or negative 40, this means that this quadratic has no solutions. Okay, there are no values of x when y is equal to 0. Okay, well, now we have an example where we have two solutions, we have one solution, and we have no solutions. It's a lot of work to go through the entire quadratic formula to prove that something has no solution or one solution. Okay, and that's why I said hold on to that thought, because what we have here is what we call the discriminant. So if I were to rewrite the quadratic formula here, just so we have it up here as a point of reference, okay, you notice, and I told you last time that there's kind of three portions to this. This portion under the square root sign is known as the discriminant. Okay, so b squared minus 4ac is a very important part to the quadratic formula for us. It's discriminant. The value of this expression, so if you take it by yourself, gives the number of real solutions to a quadratic equation. Okay, it tells you, are you going to have 2, are you going to have 1, or are you going to have 0 solutions? So, if the discriminant is greater than 0, okay, greater than there are 2 real roots. Okay, now I'm going to draw some rough sketches here. So for this example, if I had 2 real roots, okay, well, that means it's crossing this x-axis twice. So these could be examples, or it could be the other way. Doesn't really matter. You can see that clearly that these rough sketches would have 2 solutions. Now if I look at the next one, if the discriminant is equal to 0, there's 1 real root. And up top when we were doing that example, I asked you to think about a scenario where this would be true. So if I draw some additional graphs, okay, how do we have 1 solution? Well, that 1 solution is only makes sense if it happens to be the vertex. Okay, the vertex is what is touching or crossing the x-axis. So if you have 1 real root or only 1 solution, that solution is also equal to your vertex in this case. And the last scenario that we're looking at here, I apologize, is if the discriminant is less than 0, there are no real roots. Okay, and if then, how does that look on a graph when we have no solutions? Well, this is how it looks. There's just multiple ways that this never crosses the x-axis. Okay, so you can see here that I've drawn rough sketches when we have 2 solutions, we have 1 solution, and when we have 1 solution it would be the vertex, and then there are also scenarios when we have no solutions just because it does not cross the x-axis. Okay, now if I ask questions like that, so if you look in example 2, determine the number of solutions for each equation, you don't need to go through the whole process of using the entire quadratic formula. Okay, you can use just the discriminant, and we'll show you a couple examples here. first, in order to use the discriminant, we need to be working with standard form. Okay? So, what am I going to do? Well, I'm going to kind of use distributive property and expand this. This is negative x squared. Okay? That becomes negative 6x plus 4. We want to make one side equal to 0 and rearrange, which gives me this. And my resulting quadratic in standard form is negative x squared minus 7x plus 4. Okay, our a value here is negative 1. It's right there. Our b value is negative 7. And our c value is 4. So, the question is asking determine the number of solutions. If I said what are the solutions, you would have to use the quadratic formula, but it's just saying number of. Okay, so b squared minus 4ac. Plug in what you know. Well, b is negative 7. Square it. A is negative 1. And c is 4. This is 49. 4 times negative 1 times 4 is negative 16. Subtracting negative 16 becomes 49 plus 16. And that equals 65. Okay, well, that value of 65 is positive, and it's not so much that number that means importance, it's just, is it negative, positive, or 0? We would say there are two solutions because the discriminant is positive. Okay, 65 is a positive number. Two solutions to that quadratic. You could go ahead and use the quadratic formula to check that, or you could use some sort of graphing software to check your answer. Let's look at this one. Again, we're going to have a little bit of rearranging to do. Okay, so I'm going to bring that negative 2 over, becomes positive 2, equals 0, collect your like terms, and you are left with plus 5 equals 0. Now you notice this is also vertex form. Right as you see it, this would look like a vertex form. It might help if I show you it like this. But again, we're using the discriminant, so we need standard form, which means we're going to have to expand that. Anything squared is just multiplied by itself, so write it out the long way. And we're going to use FOIL to expand that. That gives me x squared minus 5x plus 25 plus 5 equals 0. If you combine all of your like terms, then you're going to be left with x squared minus 10x plus 30. Our a value is 1, my b value is negative 10, and my c value is 30. Use the discriminant. Okay, negative 10 minus 4 times 1 times 30. That's 100 minus 120, which is equal to negative 20. Now, going off what we know about the discriminant, if this is negative, therefore we have no solutions because discriminant is negative. So you don't have to use the entire quadratic formula in order to come up with that. However, I will show you a trick if you have vertex form. So let's go back to this right here. If it just asks you a number of solutions, there's a way you can just observe the vertex in vertex form. So what does this tell us? Well, this equation here tells me the vertex of this quadratic is 5, 5, and in general form vertex okay, the a value is out front. Now there's no a value that is written here, so it's 1, and it's positive 1, okay? A is positive, and you can even confirm that over here, okay? Which means the parabola opens up. If a is positive, remember the parabola opens up. So let's draw a rough sketch. So where is this vertex 5, 5? It would be somewhere right here, and this parabola opens up. As you can see, that parabola is never going to cross the x-axis, and therefore we only have no solutions as a possible answer here. So you can simply observe the a value and the vertex in vertex form in order to get that answer. Okay? So that is using the discriminant. We have one more example here, and let's get that now. Okay? So it says, in this relation, y equals negative 2x squared plus 8x plus 3, for which values of y will the corresponding equation have only one solution? Let's remember something. If we have one solution, okay, that means our discriminant must equal 0. Okay, so I'm going to show you two different ways to solve this problem. One is, first we want to identify the vertex. Okay, and there's multiple ways you can do that. Okay, we can complete the square, you can partial factor. So however way you want to find the vertex of that problem, try and do that now. Pause the video and come back and check to see if we have the same vertex. So if you complete the square, as you can see right there, the vertex you get is 2, 11. And going back to what the question says, what values of y correspond to having one solution? Remember, if we have one solution, the discriminant must also equal 0, but also that solution is the vertex. So if you get a question like this asking for one solution, what we need here is simply our optimal value, or our value of y of our vertex, which is in this case 11. So what value of y will correspond to this equation having one solution? 11. Okay, so you could say therefore y equals 11 will allow this equation to have one solution. Now the second way you can look at this is using the discriminant. And this might be a little bit more tricky algebraically. Remembering that the general form for a quadratic is this, ax squared plus bx plus c. This equation is asking, or this question, sorry, is asking what value of y, which is here, do we need to substitute in to allow this quadratic to have have only one solution. So go ahead and plug in, or just rewrite the equation up top, okay? And what I'm going to do is I'm going to bring the y over and set this equal to 0. So now we have plus 3 minus y. Okay, and if we break this apart, this is my a value, this is my b value, and now all of this is my c value. And I'm going to use the discriminant. And I want to know what is it going to equal in order to have one solution. Well, I have 8 squared, and then I have -2, and this you plug in 3 minus y. let's simplify some things. That becomes 4 times negative 2 is negative 8. Okay, and now this simply becomes an isolating thing where we need to get our variables to one side and our constants to another. Negative 64 now, minus 24 equals negative 8y. That would be negative 88 equals negative 8y, and sorry, I'll scroll up a bit, divided by negative 8 to both sides, and y is equal to 11, which is the same answer we got there. So there's two different ways that you can set that up and solve that problem. So congratulations, you've made it through quadratics. There are a few more suggested exercises and an assignment for you to finish in this unit. Enjoy.